Alrighty, folks. So today we got to start talking about the history of the atom. Now, history isn't my strong suit. Remember, I'm fairly certain that, well, all right, kids. Today we got to start talking about the history of the atom. Now, we all know that history is not Mr. Pilcher's strong suit. About the only thing I know about history is that George Washington led the West to victory in the Civil War. I think I'm like 90% sure that's right, but that's about all I got going for me, okay? So we're going to talk about the history of the atom, and bear with me because history is not, my cup of tea, my forte. It doesn't really charge me up, right? Protons and electrons. Okay, let's get started. All right. So first of all, we got to talk about what is a model. Be like, Mr. P, are you talking about yourself? Oh, no. Oh, no. I mean, a model is something that's an attempt to understand or explain things, okay? So some sort of attempt to understand or explain things. Usually they're simpler than real life. And they're usually trying to understand and explain things that are either really big or really small to work with. So, for example, I got like this little car. And we can talk about this model car. And part of the reason why we need a model car is because you're not going to be pulling your car into my classroom because it's a little too big to deal with. So we use models to try and explain what we mean when we say a car. Now, all models fall short of reality. I'm pretty sure this car probably has less than 1 horsepower. And by 1 horsepower, I mean 0. The doors don't open. These wheels, I don't know if the alignment here is legit. And last time I checked, car wheels aren't plastic. They tend to be rubber. Pretty sure on that. So models help explain things to ourselves or help us understand, or they give a simple picture of what's really going on, but they always fall short of reality. And here's a big idea that we're going to see. Over time, models will become much more complex because we're going to gain more and more information. And so we'll see that in the history of the atom, things start off really, really simple. And then as people gain more information, they get that information, they change the model of the atom a little bit to make it a little bit more complex. Then they learn new information, make it more complex, more info, more complex, more info, more complex. And so the model of the atom will get more and more complex because we're getting more and more information all the time. So that brings us to our first individual who I'd say is part of the history of the atom. It's a dead Greek dude named Democritus. Okay, and Democritus is credited for the first atoms exist theory, but he didn't have any proof. Okay, so as we go through all these dead guys in the history of the atom, what I want you to be able to do is to be able to tell me their name and basically their main contribution or two. So for Democritus, he came up with the first atoms exist theory. So what I mean by that is, if you picture Democritus, he's a Greek dude. So maybe he's just like reclining and he's like, servants, bring me more grapes. And he's like eating a grape and he bites it in half. And then he bites it in half again. And again and again and again. And he has this like amazing, conclusion or whatever. He's like, my goodness, eventually I won't be able to bite the grape in half anymore. And that tiny little piece of matter or whatever, I'm going to call that atomos. That's like the word they had for the smallest thing they could think of at the time. And that's where we got the idea of an atom. So it came from the Greek word atomos. He didn't have any proof. It's not like he conducted any science experiments in the lab. He just sort of logicked his way to this kind of understanding. Okay. Now, it turns out Democritus was right that all matter is made up of small little particles called atoms, but he didn't have any proof. And then in comes this guy. Maybe you've heard of him, Aristotle, okay? Now, Aristotle's like, bruh, what do you mean atomos? Atoms isn't a real thing. It's all about earth, wind, water, and fire. That's what everything's made out of. And so no one really believed in the whole atoms idea from Democritus. And it says back nearly 2,000 years. So Democritus was right over 2,000 years ago, but nobody believed him because Aristotle, the popular kid at school, said differently. He's like, oh, it's all about earth, wind, fire, and water right here. So to kind of understand the situation, let's say Mr. Pilcher sent out a tweet today. It's like, chemistry rocks. Okay, like 2 people are going to see that, one of them being me and the other one probably being my mom. Okay, but if Kim Kardashian sends out something, she's like, science is all made up and it's not real. More people are going to read and probably believe that, unfortunately, simply because Kim Kardashian is popular. Everyone knows who she is, even though she's an idiot. And Aristotle wasn't an idiot, but because he was so popular, people believed his very wrong theory over Democritus, who, wasn't winning prom king or anything like that. And so we're set back 2,000 years, even though we knew what an atom was, or we knew of an idea of the atom so long ago. Now, that brings us to the first guy who used evidence of atoms. His name was Antoine Lavoisier. He was French. The little IER sound kind of becomes Lavoisier. So he worked for the French government. He was sort of a tax collector. And he's the first guy who is credited with the law of conservation of mass. So the idea that mass before equals the mass after. So this is something that we're familiar with from a couple units ago. So he was doing this reaction right here. So we have sulfur dioxide plus water. And he realized, like, okay, if I have 5 grams of this at the beginning, I'll end with 5 grams of this at the end. And here's kind of what went down. So like SO2 plus H2O makes H2SO3. So he realized, like, okay, so we started with 2 H's and we end with 2 H's. We started with 1 S and we end with 1 S. We started with 3 total O's and we end with 3 total O's. And so he realized that matter cannot be created or destroyed. Now, here's his problem, okay? So he worked for the French government in the 1700s. And if you know anything about history, the French government went a little cray-cray back then. We had the French Revolution. And you know what they loved to do to smart people back then? Yeet! They loved to cut their heads off. And that's exactly what happened to Antoine Lavoisier. So his head was cut off, and the story goes, they chopped his head off, they picked his head up out of the basket, and he blinked exactly 17 times. And it's a fairly documented incident, and like several eyewitnesses claim that they saw him blink 17 times after his head was cut off. So I don't know if 17 was like his favorite number, or it's like, oh, it's the 1700s. Not really sure what the deal is there, but yeah. So his main contribution was that he is sort of the father of the law of conservation of mass, which is a pretty big deal. Next up, enter this guy. I don't want to close this. His name is Joseph Prost. Joseph Prost, about 20-some years later. And he is credited with the law of definite proportions. The law of definite proportions. And so what this is saying is that each chemical compound has a fixed and unchangeable ratio of its elements. Each chemical compound has a fixed and unchangeable ratio of elements. So what this means is every time you have a compound, so let's say every time you have a water, it's always 2 hydrogens and 1 oxygen. Like every single water is 2 hydrogens and 1 oxygen. And how this came about was that a bunch of Europeans were arguing about whose water is better. So you had France over here, they're like, our water is definitely better than everyone else's water. Then you had England over here, they're like, our water is superior to your water. And so Proust is like, all right, let's get a little bit of water from all these different European countries. We're going to take them to the lab, and we're going to test experimentally whose water is the best. And you know what he found? Everybody's water had 2 H's and 1 O. Every single molecule of water was 2 H's and 1 O. And so he realized, okay, every chemical compound has this fixed and unchangeable ratio. There's nothing you can do about it. So every time you have a water, that requires a couple of H's and an O. Couple of H's and an O. Couple of H's and an O. Okay? And, you know, this is a pretty big deal because if you change this even a little bit, so H2O is the elixir of life. You need it within 3 days or you'll die immediately. But if you change it just a teeny bit to H2O2, That's called hydrogen peroxide. It's used in rocket fuel, and you can use it to bleach your hair, which is kind of crazy. So this is a really big difference going from H2O to H2O2. That unchangeable ratio matters quite a bit. Next up, we're talking about this guy who looks like a middle-aged Harry Potter. His name was John Dalton. All right. So what was Dalton's deal? Well, imagine this. So Dalton was a fairly sharp dude. By the time he was 12, he was actually a school teacher. So he's kind of ahead of the class, so to speak, there. But he was fairly clumsy. So when he got to the lab, he was always tripping. He was breaking stuff. He'd drop all the test tubes and they shatter, that kind of thing. So you can imagine his colleagues are sort of like, all right, John, how about you sit in the corner over here? And no, put that down. Okay, don't touch anything. And why don't you just use that big brain of yours and just think? And seriously, don't touch anything, okay? And so that's exactly what he did. And during that time, he thought of Dalton's atomic theory. Dalton's atomic theory. Now, there are 4 parts of Dalton's atomic theory, and some of them should sound kind of familiar. So part 1, all matter is composed of atoms which are indivisible, not invisible like you can't see them, indivisible, which means you can't break them into smaller pieces, and indestructible. So hopefully this is familiar to you, where you're like, okay, atoms, all matter is made out of atoms. Isn't that like what Democritus already said like 2,000 years ago? Like the whole atomos idea? Like, yep, that's right. Like, okay. And indivisible and indestructible? Well, that's what Lavoisier already said with the law of conservation of mass. Like, can't destroy mass or create it 5 grams before or 5 grams after. Like, yep, that's right. Like, okay, cool. Part 2, all atoms of the same element are identical. So that means that all carbon atoms are identical to each other. So if 2 atoms are a carbon, they're identical in every way. Now, we know that's not true today, but remember, this is back then. This is the first, this is the beginning of, like, you know, the idea of atoms and that kind of thing. And so this is what was part of Dalton's atomic theory, and this is an important step along the way. Part 3 is similar. All atoms of different elements are different. So all carbon atoms are identical to carbons, but carbon atoms and sulfur atoms are not the same. They will have different properties. Okay, they will not be identical like atoms of the same element. Like, all right, straightforward. And the last rule should sound a little familiar too. Compounds are composed of 2 or more different elements in a definite ratio. It's like, okay, isn't that what Prost already said, though? Remember the H2O guy who's comparing the waters? And like, all right, all water is 2 H's, 1 O. Like, yep, that's right. And so Dalton's atomic theory is pretty readily accepted because part 1 and part 4 were based on views that people already believed in. And you don't have to write this little chunk down right here. That's kind of why it got a lot of momentum pretty easily. And so you're like, okay, so you pretty much just used other people's work and slapped your name on it. Like, yeah, Dalton's atomic theory. What's up? Like, okay. So you need to know Dalton's name. You need to know that he came up with the atomic theory and that there are 4 parts to it and what those 4 parts are. And lastly, you need to know, and this part's pretty significant, that he was the first guy to come up with a model of an atom. First guy to come up with a model of an atom. And his model was a marble. Okay? There's no specific parts of an atom. It's just simply atoms are just like a marble, or sometimes you'll hear this called Dalton's billiard ball model. So you can kind of imagine, it's like, all right, people, ready? Drum roll, please. Here's my model. Boom. Woo. Check that out. It's a ball. You're like, okay, there's nothing else to it. Nope. All atoms, the smallest things in the universe, look just like this. Little ball. Like, oh, okay. Well, that's exciting. But, you know, this isn't really that cool to look at, but at the same time, this is a pretty significant step. This is the first time someone tried to create a model of an atom. So although we know this isn't really that accurate today, it's significant because it sort of got us on the right path. So here we go. Dalton's marble model of an atom. That's what you need to know about him. And so here's middle-aged Harry Potter. And of course, I like drawing a little lightning bolt on him. Wah, 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 wah. Do you guys get it? That's the Harry Potter theme song. Harry Potter. Oh, yeah. Mr. Pilcher still got it, even during remote learning. Whew. Yeah, we're all charged up. Atoms. History of the atom. Yeah.